In today's video, we're breaking down the mystery behind the sounds high-voltage wires make. You'll learn.
Welcome to Electro-Tunes CEWP.
Understanding the buzz, why high-voltage wires make noise. Ideal for YouTube, training sessions, or educational purposes. Hello everyone, and welcome back to the channel. Have you ever walked under high-voltage transmission lines and heard that strange buzzing, crackling, or humming sound? If you've wondered what causes that, you're in the right place. In today's video, we're breaking down the mystery behind the sounds high-voltage wires make. You'll learn why the buzzing happens, what causes it scientifically, when it's normal and when it's not, and how it's managed in the electrical industry. Let's dive into the science, sound, and safety of high-voltage lines. What are high-voltage transmission lines? Before we understand the noise, let's understand what high-voltage power lines actually are. These are overhead or underground conductors that carry large amounts of electricity over long distances, typically from power generation stations to substations. Voltages usually range from 69 kilovolts to over 765 kilovolts. The higher the voltage, the more efficiently electricity travels over distance. Because of these extremely high voltages, the air and environment around these lines behave differently, and that's what causes the noise. The noise you hear is known as the corona discharge effect, and the resulting sound is often called corona noise, electrical hum, or simply transmission line buzz. It can sound like a faint hum, a sizzling or crackling noise, or even a sharp buzz, especially during damp or foggy weather. Scientific explanation: the corona effect. Let's get into the science. The primary reason high-voltage wires make noise is due to the corona effect. The corona effect happens when the electric field strength around a conductor becomes strong enough to ionize the air around it. Here's how it works. Air is normally a good insulator. But at very high voltages, the electric field exceeds 30 kilovolts per centimeter, which breaks down air molecules. These molecules become ionized, they lose electrons, forming plasma around the wire. This plasma causes tiny discharges, like micro-lightning, which create that audible buzzing or crackling sound. This is especially noticeable on sharp points on the conductor. In moist or rainy conditions, when dust, insects, or water droplets are present on the surface. So yes, what you're hearing is literally electricity breaking down air molecules around the wire. Why is the noise louder in humid or wet conditions? You may notice the buzz gets louder at night, in the rain, or in foggy weather. Why? Here's why. Water droplets and moisture enhance the ionization. If you enjoyed this video and learned something new, make sure to like, comment, and subscribe. And remember, electricity is powerful, fascinating, and full of buzz, literally. Stay safe, stay curious. Other sources of noise in high-voltage systems. Besides the corona effect, there are a few other sources of noise in high-voltage lines. Magnetostriction. In transformers and conductors, the core materials can slightly expand and contract when exposed to alternating magnetic fields, producing a low hum. Vibration of conductors, wind or mechanical tension can cause cables to oscillate or vibrate, especially in bundled conductors. Discharge at insulator junctions. If insulators are damaged or dirty, they can also cause arcing or discharge sounds. Still, the most common and dominant cause of noise remains the corona discharge. Many people ask, is this buzzing dangerous? The sound itself is not harmful to people unless it reaches very high decibel levels, which is rare. In fact, most corona noise is under 60 decibels, which is about the level of a normal conversation. However, it can be a nuisance in residential areas if lines pass too close to homes. But while the sound isn't dangerous, it can indicate energy loss in the system, which we'll discuss next. Corona loss energy wasted. The buzzing sound is not just a curiosity. It represents a loss of electrical energy. During corona discharge, some of the electrical energy is converted into heat, light, ozone, and sound. This is called corona loss, and while small, it becomes significant over long distances and high voltages. That's why utility companies try to minimize corona effect to save energy and reduce noise pollution. How is the noise controlled? Here's how electrical engineers and utility companies reduce the corona effect and the buzzing sound. Using larger conductors, larger diameter wires have lower surface electric field. Using bundled conductors, multiple conductors per phase spread the electric field and reduce corona intensity. Smooth conductors, smooth, round wires reduce sharp points where discharges start. Proper insulation and cleaning, clean insulators and protective coatings help reduce ionization. Weather-resistant materials, some modern conductors are treated or coated to handle humidity better. This not only helps with noise reduction, but also increases efficiency and safety. Real-world applications and inspection. In real-world applications, detection tools like ultrasonic sensors, corona cameras, or RF interference meters are used to detect corona discharge, especially during maintenance checks. Utility companies also conduct regular inspections via drones to check for excessive corona activity or worn components.